So here is a system, here is a diagram, basically a simple circuit that has a power supply and two resistors that are connected in parallel, parallel with a current of 1.2 amps flowing into both of them. All right, so we are going to be solving this particular question and also applying Ohm's law that we saw earlier. All right, so let's see the solution quickly. Now recall that we have two resistors that are connected in parallel. So the first thing we'll do is that we'll list out our parameters. Let's list our potential difference. In this case is given to us as 12 volts. The current that flows through this particular circuit is 1.2 amps. And then the resistors, let me call this one R1 and R2. They happen to be of the same value. So I'm going to say R1 is equal to R2 and it is equal to 40 ohms. All right. So to solve this question, I know now that I have two resistors connected in parallel. So I will have to look for their effective or equivalent resistance. To do that, let us recall that for parallel connection of resistors, let me just put R. Okay, parallel connection of resistors R. The formula is giving us 1 over Req. My EQ is like saying the equivalent resistance of the resistors. All right, so this will be equal to 1 over R1 plus 1 over R2, so that I can obtain the equivalent or effective resistance in this whole circuit. So to do this, 1 over Req will now be equal to 1 over 40 plus 1 over 40. This would lead us to 40 over 1 plus 1, and there will be 2 over 40, which if we break down further will give us 1 over 20. But here is not the final answer. Some students usually make this particular mistake of leaving it as 1 over 20. I have to turn this over. I have to take the inverse of this particular fraction, and when I do that, I will have that the effective or equivalent resistance in this circuit is equal to, if I turn over, it becomes 20 over 1. That is equals 20 ohms. This is not zero anyway, this is ohms. Okay, so it's 20 watts ohms. That's the equivalent resistance in this particular circuit. Now here's where we will now apply Ohm's law. From Ohm's law, we know already that the potential difference is equal to the current that flows through a circuit or through a metallic conductor times the electrical resistance. But then there's another information as we go into the question proper. It says calculate the total energy developed in 5 minutes by the system above. All right. Now we should recall that its energy in an electric circuit is given as IVT. All right, IVT, or better still, if V is equals IR, anywhere I see V, I'm going to replace it with IR. That will turn to I squared RT. Is that okay? So we already have our time. Our time was given as 5 minutes. So if our time is 5 minutes, that will mean that I need to convert my time, which is in 5 minutes, to seconds. And we know that 60 seconds make 1 minute. So this will be 5 times 60. That is 300 seconds. 300 seconds is our time. So therefore, electrical heat energy developed in 5 minutes, which is now in 300 seconds, will be equal to, the current is given to us as 1.2 amps. 1.2, and the square of it, because I squared, so the square of it, times the effective or equivalent resistance in this circuit. That will be 20 times the time, that is 300. Okay, so this will go to be, if I take 1.2 squared, 1.2 times 1.2, that will give me 1.44 times 20 times 300. So let's take the product of all of this. 1.44 times 20 times 300. So at the end of the day, the electrical heat energy developed in 5 minutes is giving us 8,640 joules. Or if I put this in kilojoules, it's become 8.64 kilojoules. So in this particular system, as we can see here, the electrical heat energy developed in 5 minutes is giving us 8,640 joules or 8.64 kilojoules. Alright, so do not forget the major things we mentioned. Resistors connected in parallel, you will need to get the equivalent resistance, and then the formula for electrical heat energy, IVT, or better still, I squared RT. Thanks for going through this video. I really appreciate. Now, if you have a question as relating to something like this, or there's something you think I did not mention, do it to drop that information in the comment section and we'll look into it. Thank you very much.